Hi, I'm RL from MathinSG.com, and in this video here, I'll be going through the 2024 H2 A-Level Math paper, Paper 2, Question 2. The full work solution can be found here at this website here. I'll provide the link in the description below. So now let's go through this question. This is an application of differentiation to maximum and minimum problems. So let's read. A gardener designs a flower bed A, B, C, D, E in the shape of a rectangle with an equilateral triangle on one of the shorter side. Okay, side AE is of length A and ED is of length B. The total perimeter of the flower bed is 20 meters. Okay, so they gave us the total perimeter of the flower bed. So I should form an equation with the perimeter. Okay. So here I know that this is A because this is an equilateral triangle. Here's also A, here's also A. So in other words, the perimeter of the flower bed is 1, 2, 3, 3A plus 2B's will give me 20. I need this equation because there are two variables A and B. And when we do maximum minimum type of questions, right, you try to form an equation with just one variable, one other variable. Okay, I'll talk more about what I meant later. So maybe I will make one of them the subject here because I know that later I need to get rid of one of them. So I'll make B the subject, for example. Okay, so next, find the maximum possible area. So I want to find the maximum possible area. And I want my area to be in terms of either A or B only, not both. Okay, then it is easier for me to do the differentiation and then find maximum or minimum. Okay, so let's do that. So I'll let uppercase A be area of flower bed in meters square. Okay, so the area of the flower bed will be equals to the area of the rectangle, which is A times B, plus the area of this triangle. I do not have the height. Okay, so but I know that for an equilateral triangle, all the angles are 60 degrees. So I can use half times A, which gives A square, sine 60 degrees. Okay, which will give me sine 60 degrees is root 3 over 2. Okay, I also want to sub in my B because later on when I differentiate, I only want to differentiate A against small a. Okay, so root 3 over 2 times half is root 3 over 4. So let me change everything to root 3 over 4. So expand it, then divide by 2. So it's 10a minus 3 over 2a square plus root 3 over 4a square. Okay. Next, they ask us to find the maximum possible area of the flower bed. So I'll find dA, d small a. So differentiate this, I'll get 10 minus 3a plus root 3 over 2a. Okay, so I will also find d square a dA square, which is 10 it's minus 3 plus root 3 over 2, which when you type in into your calculator, it is lesser than 0. So the stationary value is a maximum. Okay, so this one I'll write it later, not now. So once I have differentiated it, I need to let dA, d uppercase a, d lowercase a equals to 0. Okay, so a is equals to 10 over 3 minus root 3 over 2. Okay, then uppercase, this a is equals to this. Okay. Because everything can be typed into the calculator, so just type it into the calculator. Okay, because they want 4 significant figures, so you get 23.43 for significant figures. Okay, so here well, maybe I should write it here actually. Okay, so therefore required area equals to 23.43 meters square. In fact, you can actually just use your GC, type this equation in, then just look for the maximum point, okay, using your GC, and then you can check your answer. Make sure that is 23.43 when rounded off to 4 significant figures.